Over the last 2 decades, fiber optic systems have replaced the copper transmission systems of the past. Working with optical fibers and optical connectors is much more critical than their copper counterparts. Throughout the installation, splicing and connectorizing of optical fiber and the need for cleanliness is the single most important issue facing the fiber craftsperson. With today's reliance on gigabit rate transmission and the evolution to DWDM networks, cleanliness becomes even more important in the operation of these high-performance fiber systems. Before we can clean optical connectors effectively, we must first understand how connectors get contaminated in the first place. By far, the most common source of contamination plaguing connectors is in the form of airborne particles. The air is full of dust, pollen, smoke, water, and chemical vapors, as well as microscopic oil droplets from numerous industrial and biological sources. This contamination covers everything in the environment near the fiber system equipment. Humans and their clothing are efficient carriers of contamination. Thus, it is very simple for contamination to be transferred to connectors from surrounding surfaces, general handling, as well as the air itself. There are 3 types of environment where fiber optic connectors will be found. In laboratory settings, you will usually find some type of controlled atmosphere to reduce contamination. This may be as simple as a closed room with hard, clean surfaces and limited access. In some cases, the room may be hermetically sealed with a pressurized environment. High-performance filtration systems remove all particulate matter, provide precise temperature and humidity levels, and workers must wear special protective clothing to avoid contaminating the work environment. The amount of contamination found on connectors in lab environments is considerably less than in other areas, but cleaning procedures are still required. In the manufacturing environment, surroundings will have much more contamination than in labs, and cleaning becomes more important. Manufacturers have become keenly aware of the role that contamination plays in the quality of their products and strive to keep the work areas as clean as possible. Workers ensure that connectors are thoroughly cleaned during assembly operations. Specialized equipment is now available to provide consistent, high-quality results when cleaning fibers and connectors prior to termination. Automated equipment makes manufacturing processes easier. Here, a new product shown at the Optical Fiber Conference features a polisher, inspection scope, and return loss meter integrated into a convenient production instrument. It is in the user environment, however, that the most serious problems with contamination occur. Fiber optic systems are often located in dirty locations such as entrance facilities, janitor's closets, boiler rooms, and basements. In these places, it is very easy for contamination to work its way into precision optical connectors, degrading system performance. Thus, it is the user environment that must be given the most attention in connector cleaning. In the past, lower speed, lower power systems were able to tolerate moderate amounts of contamination. Since the early 1980s, connector designs have featured physical contact of ferrules to obtain the lowest attenuation and reflection levels. The role of connector cleaning was primarily to remove large particulate matter to prevent surface damage during mating and improve physical alignment of the connector components. Alcohol-soaked pads were the cleaner of choice, while some technicians inappropriately wiped the connectors on their shirts. Bad cleaning habits evolved over time due to a fundamental unawareness of the importance of proper cleaning. Average airborne dust particles are on the order of 2 microns in size, while average smoke particles can range from 3 to 5 microns. A number of these particles could settle on the 62.5 micron core area of a multi-mode connector before a performance reduction would be noticed. However, single-mode fiber cores are only about 9 microns in diameter. In this case, even one dust particle can block more than 10% of the transmission area. When connectors are mated repeatedly, normal wear can shave tiny flakes of metal from the internal alignment sleeve, as well as very fine ceramic dust from ferrules. This material may accumulate and contaminate the connector. Another point to consider is that every time a connector is pulled from its mating sleeve, a vacuum is formed within the sleeve that sucks in contaminants that may be floating in the air nearby, so the more you mate the connection, the dirtier it gets. Oil vapors can adhere to internal parts of the connector, attracting and holding airborne particles. As the grime accumulates, it forms an abrasive that can scratch the precision optical surfaces of connector ferrules during mating. This is particularly true of high-performance PC-style connectors. Even the tiniest scratches on DWDM connectors can result in severe performance degradation. Once the connector is damaged, no amount of cleaning will restore it. Replacement or repolishing is the only option. Oily residues can also cause high reflectivity at connectors, which can show up as increased bit error rates in high-speed systems. DWDM systems are extremely sensitive to even minute amounts of contamination. What is worse is contamination, such as oil residues, may affect some wavelengths more than others, so the technician may suspect a problem in individual transmit-or-receive circuits when the real culprit is a dirty connector. In order to keep connectors clean and undamaged, it is very important to observe correct handling procedures. Pay particular attention to alignment while mating connectors to avoid dragging the optical surface along the inside wall of the coupling sleeve. Hold the connector so that the ferrule passes straight through the center of the sleeve. Always keep unused connector ports capped, and store unused caps in a small Ziploc bag inside the equipment rack for easy access. The bag will prevent dust from accumulating in the caps and being transferred to the connectors. Remember, however, that all plastic covers contain oils that can outgas and contaminate the connector over time. Covers are most useful in keeping large particles out of the connector. Never allow connectors to come in contact with any surface when not mated. While temporarily disconnected, hang the connector over a table edge or other convenient support to allow it to be suspended in mid-air. Be sure the connector cannot collide with other connectors or with any other surface while suspended. When disconnected for extended periods, cap the connector ferrule to prevent contamination and scratches. Some of the more recent connector designs feature internal automatic dust caps that deploy the instant the connector is unmated. Never touch a connector ferrule with your fingers. An astonishing amount of skin oil will adhere to the ferrule from even the cleanest hands. Store unused jumpers with connectors capped in Ziploc plastic bags and place them in boxes or other containers where heavy articles will not come in contact with them. Plastic video cassette boxes are a convenient option. It is important to be able to verify the condition of connectors used in fiber systems. How clean are they? Are they scratched or damaged in any way? Being able to answer these questions is key to keeping high-speed fiber networks operating efficiently. A number of inspection scopes are available to examine connectors. Handheld microscopes allow the technician to closely view the connector ferrule. Scopes are most commonly available with 200 or 400 power magnifications. The 200 power scope can show sufficient detail when inspecting multi-mode connectors. However, when testing single-mode connectors, the use of 400 power or stronger scopes must be used. When using optical scopes, be absolutely sure that the connector you are viewing is not live. Although many scopes have internal laser filters, the high laser power levels used in modern fiber networks like CATV and DWDM systems can potentially cause instantaneous and irreversible eye damage if the beam directly enters the eye. Never trust your sight to any optical filter. There are also a number of video-based inspection scopes available. These scopes can be safer to use than their optical counterparts, as there is no chance for a stray laser beam to enter the eye during their use. There are video scopes designed specifically for examining connector ferrules, as well as scopes that can be inserted in bulkhead connectors found in patch panels or in media outlets. And some scopes can be configured to do both jobs. As with optical microscopes, video scopes are available with different magnifications, so be sure to use at least 400 power with single-mode connectors. No matter which scope you select, be sure to follow all manufacturer's instructions and safety recommendations. When examining connectors, be sure that there are no scratches, pits, or cracks on the ferrule end. If you see any of these defects, especially over the fiber core, the connector must be replaced or repolished. Dirt, thick residues, and other large contaminants will be easy to see. However, fine residues from water and oils may be more difficult to find. Fine residue can be detected more easily by the use of a small visible laser. When the beam passes through the connector, residue will severely scatter the light, causing the ferrule end to glow brightly. A clean connector will exhibit very little scattering. All connectors in the fiber system should be checked with the inspection scope prior to mating. This includes the connectors on circuit cards as well. Even when installing a new circuit card or piece of fiber optic equipment, never assume that because the product is new, the connectors will be clean and free of damage or defects. In fact, new connectors are often too dirty to put into operation because of residue from the manufacturing process or dirt accumulated during shipment. This inspection scope is customized for aerospace connectors and features an XY positioning feature to allow inspection of individual pins or sockets in these multi-pin connectors. The connectors on test equipment such as OTDRs, optical spectrum analyzers, and other high-performance instruments require 100% inspection and verification every time the instrument is used. It is critical that the connections on these instruments remain clean and undamaged. Clean is a relative term, however. A ferrule end that is clean enough in one system may still be too dirty in another system. Today's systems using high-power lasers, extremely high bit rates, and multiple wavelengths now require strict attention to cleaning practices and the use of premium-grade cleaning products to maintain the quality of the connection surfaces. A variety of products have been developed over the years to address the issue of connector cleaning. These include canned air products for blowing away dust particles, cleaning pads soaked with alcohol or other solvents, cleaning swabs for sleeves and bulkheads, as well as a number of dry and adhesive tape products to remove contaminants from connector ferrules. Regardless of the type of connector or the system where it is used, the basic steps for connector cleaning are the same. First, connectors are disconnected from both sides of the sleeve. The sleeve is then cleaned to remove loose dust. Finally, both connector ferrules are thoroughly cleaned before the connection is remated. Once disconnected, a compressed gas duster is used to blow dust particles out of the bulkhead connector sleeve. Most of these products use a liquid propellant that produces a powerful blast of inert gas. Be careful when using dusters in poorly ventilated areas, as they can pose a health hazard. The first blast should always be into the air to clear any dirt from the nozzle. Use the canned air in bursts instead of a continuous blast. This method is more efficient in removing particles and is also less wasteful. To get the more stubborn grime out of a connector sleeve, a swab is used. These swabs are available from a number of manufacturers and are selected to match the ferrule diameter of the connector, such as 2.5 or 1.25 millimeters. They are manufactured with materials that will not contaminate the connector. Never use store-brand cotton swabs, as they contain excessive lint which makes them undesirable. The swab is inserted in the sleeve while rotating clockwise and pushed completely through the sleeve. Between 4 and 6 rotations of the swab should be completed before the swab exits the sleeve. Direction of rotation is of critical importance when using some types of swab. In this example, the swab has a tip made from a special microcellular foam that is very effective in removing micron-sized contaminants. The foam is wrapped helically around the handle and when rotated in a clockwise direction, acts like the flutes of a drill bit to auger contaminants out of the sleeve. Swabs are usually used dry, but in cases of severe contamination can be saturated in solvents such as isopropyl alcohol to break up stubborn grime. If alcohol is used, be sure to use reagent-grade 99% alcohol rated for cleaning fiber optics, not store-brand rubbing alcohol which can contain more than 30% water. When the sleeve has been sufficiently cleaned, we can move on to the connector ferrules. In the past, cleaning connector ferrules was usually done using pads pre-saturated with isopropyl alcohol. Two types of pad are commonly used in fiber optics work. Alcohol-soaked pads are soft and fully saturated, while optic pads are a fine lens paper only slightly moistened with alcohol. Alcohol pads find extensive use in removing cable gel and plastic residue when preparing cables and stripping fibers. Optic pads are more suitable for connector cleaning than alcohol-soaked pads unless a large amount of dirt must be removed, as in the case of a connector dropped on the floor. Alcohol-based products are inexpensive, easy to use, and have been used for decades to provide acceptable results in low-speed multi-mode systems with LED sources. First, fold the pad over to form a small cushion. Hold the connector vertically as shown here, and lightly wipe the ferrule end face over the optic pad. Repeat this several times, being sure to use a fresh section of pad for each pass. Then, use the pad to clean the sides of the ferrule. This removes particles along the ferrule sides to improve mating alignment and to prevent contaminants from being pushed into the connector. The alcohol will evaporate very quickly from the pad, leaving dry lens paper. The connector end should be passed over a clean section of dry paper at least once to remove alcohol streaks on the ferrule. Do not touch the mating surfaces or place the connector on any surface before remating. Connectors used in higher speed systems require more careful attention during cleaning. Single-mode connectors have precision optical surfaces that are more critical than the lenses of the finest camera equipment. This is why you will never see a professional photographer cleaning his lenses with any alcohol products. The reason is that alcohol is hygroscopic. It attracts moisture from the air. In many environments, serious contamination can be accumulated on the pad within seconds after removing it from its packaging. Along with water vapor come tiny particles of dirt, smoke, and pollen, along with droplets of oil from both mechanical sources, like fans and heating systems, as well as biological sources, like human breath, and even nearby food. When the pad is used to wipe a connector end face, contamination can be smeared across the surface, resulting in a type of signal loss called haloing. This effect is identical to the process used in soft focus filters for photography. The filters use an ultra-thin particulate layer to scatter light rays from the bright spots in a scene. Although sometimes useful in photography, the effect can be disastrous in a fiber optic connector, especially in a DWDM system. DWDM depends on faithful transmission of multiple wavelengths on a single fiber. The contamination can affect certain wavelengths more than others, leading to high bit error rates on some or all channels. As a result, alcohol pads and solutions should never be used to clean high-performance connectors. A number of companies have developed alternative products to safely and effectively clean connector ferrules. Most are used dry to avoid attracting airborne contaminants. Among the most popular are the dry tape-based cleaning cassettes. To use this type of cleaner, the tape is first advanced to expose a fresh, unused section. A small flap protects the tape from airborne contamination until the instant the technician is ready to use the tape. The flap is retracted and the connector held in a vertical position. Lightly press the ferrule against the cleaning tape and slide it along the surface of the tape. The tape is wide enough to allow 2 passes of the ferrule over a fresh section of tape. This model of tape cleaner has 2 defined slots for the ferrule to pass through. Both slots must be used to ensure a clean ferrule end. When finished, the protective flap is closed on the cassette. To be sure the connector is actually clean, you can inspect it with your scope. But be sure the connector port on the scope is also clean to avoid transferring dirt to the newly cleaned connector. Sometimes it may be difficult to determine if the contamination you are seeing is actually on the connector or on the optics of your inspection scope. One way to tell is by rotating the connector while viewing. If the contamination rotates, it is on the connector. If it remains stationary, the dirt is in the inspection scope. When you see a clean connector, immediately reinsert it into the mating sleeve or bulkhead. If the inspection scope indicates that the connector is still dirty, repeat the cleaning procedure. Sometimes it may require 3 or 4 cleaning operations on a connector before all contaminants are removed. If the problem still persists, try using an optic pad to wipe the connector ferrule. Then, immediately use the cleaning cassette 3 or 4 times to remove the alcohol residue before inspecting the connector again. If the connector cannot be cleaned, you may be seeing ferrule end damage rather than simple contamination. In these cases, the connector must be replaced or repolished. Although highly effective, the mechanics of cleaning cassettes can be awkward to use at times. And because they require the connector to be wiped across a surface, there is a slight possibility of scratching should an abrasive particle find its way onto the cleaning tape. The protective flap may not exclude these particles, especially if the cleaner is kept in a dirty environment, like the average toolkit or a dusty pocket. To reduce the possibility of damage, keep the cleaning cassette in a Ziploc bag and change bags periodically. This tape-based cleaner, however, can be safely and conveniently kept in a shirt pocket. To use it, a cleaning sheet is removed from the case. Each sheet has a number of slots containing cleaning tape, covered by a protective plastic film to keep contaminants out. Peel back the protective film from the next available slot. Place the connector ferrule at the top of the slot and slide it down the strip of cleaning tape using slight pressure. To ensure a clean ferrule, repeat the process with a fresh slot. This disposable pocket-sized cleaner does not require wiping of the connector ferrule, reducing the possibility of scratching. The cleaning card consists of a number of cleaning ports. The connector ferrule is simply pressed firmly to the adhesive tape in one of the ports and immediately removed. The adhesive will pull contaminants from the ferrule end. Each port is only to be used one time, and it is important not to rotate the connector while it is in contact with the cleaning port. Rotation will force adhesive to stay on the ferrule end, contaminating the connector. It could also cause scratches if abrasive grit is present. The cleaning card can also be carried in a pocket, but should be placed in a plastic bag before doing so. This will prevent dust, lint, and grit from contaminating the ports on the cleaning card. A number of cloth cleaning pads are also available for optical connectors. These cleaning sheets are superior to lens paper and other tissue papers in that they are not abrasive, will not tear, and will not produce lint as the connector is wiped across the surface. Their surface is slightly textured to catch and remove all types of contaminants, and they can be used wet or dry. When using liquid solvents, remember that alcohol is not recommended for high-speed single-mode connectors, especially those used in DWDM systems. Instead, some manufacturers provide liquid solvent that contain no alcohol, will leave no residue, and can be helpful in removing stubborn grime or oils from connector ferrules. Place 4 or 5 pads on the work surface to provide a soft cushion for the ferrule. Spray a small spot of solvent on one side of the top pad. Hold the connector vertically and place it firmly on the wet spot. Wipe the ferrule surface from the wet area to the dry area. Repeat this 3 or 4 times using a fresh section of pad each time. Finish the cleaning process by wiping across a fresh section of dry pad 2 or 3 more times. Then, scope the connector to verify cleanliness and repeat the cleaning if necessary. Angled physical contact, or APC connectors, are found on many high-performance fiber networks. Cleaning these connectors requires a slightly different approach than the cleaning of ferrules with flat ends. Instead of holding the connector perfectly vertical during the cleaning process, angled connectors must be held on a slight angle. The key point to remember is that the ferrule end face must be held flat against the cleaning surface. With cloth pads, an easy method is to hold the pad in one hand while holding the connector in the other. In this way, you can feel the ferrule surface through the pad and can adjust its position accordingly. With tape cleaners, you will need to initially judge the correct position by eye. Feel is also important. When improperly positioned, you will feel resistance as the ferrule edge is the only part that contacts the cleaning surface. It will feel like you are scratching the cleaner surface. When positioned at the correct angle so that the ferrule end is parallel with the cleaning surface, the feel will be smooth as the connector is moved. With practice, you will quickly develop the proper feel for cleaning angled connectors. Connectors that cannot be accessed from both sides can be difficult to clean. These include media outlets, as well as transmit and receive ports on equipment or circuit cards. This means that the optical surface must be cleaned while in the connector sleeve. The first step is to blow out large particles using a canned air duster. Use short, gentle bursts to prevent abrasive particles from sandblasting the precision optical surface. In this application, it is also extremely important to observe the correct operating position of the duster you are using. The liquid propellant in most dusters requires vertical operation with the nozzle upright. If used in more horizontal positions, you will get a freezing blast of propellant instead of dry gas. The extremely cold liquid will be forced into the connector, instantly freezing the fiber end face inside. Such a rapid temperature drop could easily cause the glass end face to crack, ruining the connector. Even if the connector is not damaged, the liquid will leave a contaminating residue. Some dusters are designed for use in more horizontal positions, but if completely inverted, may still eject liquid propellant mist. This duster uses high-pressure carbon dioxide gas in place of a liquid propellant. This duster can be safely used in any position, but costs much more than conventional dusters. After using the duster to remove any large particles, the optical surface can be cleaned with a swab. This swab is designed to clean optical surfaces at the end of a coupling sleeve. It consists of a wooden handle with a small button of adhesive foam at the end of the swab. It works the same way as the touchpad we looked at earlier. Simply insert the swab into the connector sleeve until it firmly contacts the optical surface. Then, pull the swab straight out of the connector. Be very careful not to rotate the swab while it is in contact with the optical surface. To do so may leave behind adhesive residue. Whichever swab you use, extreme care must be used in cleaning transmit and receive ports. Unlike a jumper that can be easily replaced or repaired, a damaged laser or detector can be extremely costly to replace. During any connector cleaning, keep the following points in mind. Always scope the connector before and after each cleaning procedure to verify cleanliness, and mate the connector as soon as it is clean. Avoid the use of alcohol products on high-performance connectors unless they are badly soiled. Then, clean all traces of alcohol residue from the connector. Swabs, pads, and cleaning tape sections must be used only once. Use a fresh cleaner to repeat the cleaning procedure as many times as needed, usually 3 to 6 times for most connectors. Although you may consider this wasteful in cleaning materials, the cost of allowing a dirty connector to slip past you can be disastrous, especially in DWDM systems. Be careful of rotation when using swabs. Never rotate a swab that uses an adhesive pad to pick contaminants off a connector ferrule. Other swabs should be rotated clockwise to prevent the swab end from detaching from the handle. Consult the manufacturer's specifications if you are unsure. Always place a protective cover on the bulkhead or connector ferrule when not in use. But even if a connector is capped, it still must be cleaned just prior to mating. In modern high-density fiber systems, much attention has been given to placing multiple transmit and receive functions on circuit cards for improved efficiency and to save valuable space. Thus, optical backplanes have appeared to meet the demand. Rack-mount circuit card cages are notorious places for the collection of dust and other contaminants. Although they are often difficult to access, optical backplanes and their corresponding card edge connectors require serious attention to cleanliness. Because of the many different backplane styles in use today, you must consult manufacturer's instructions for the individual style of backplane you are using. And finally, always keep your work area as clean as possible to minimize the risk of contamination. As with many other aspects of working with fiber optics, Safety must be foremost in your mind at all times. Never clean or scope connectors on a live system. Modern lasers can produce powers in the plus 17 to 20 dBm range that can cause irreversible damage if the beam enters the eyes. Cleaning chemicals can be hazardous to your health in both liquid and vapor forms. Always consult the material safety data sheets for the chemicals you are using to determine safe exposure levels and handling guidelines. Connector cleaning has become a critical component in the operation of modern gigabit rate optical transmission systems. Today, it is absolutely essential to routinely clean and scope all connectors in DWDM systems. It is up to the fiber technician to learn and practice the proper cleaning techniques to safely and efficiently maintain these all-important connections.